Good morning, sir. Myself, Karthik, me and my team are going to explain about emotion-based music recommendation system, which is implemented in Apache Spark. Now let's go through our project. Problem statement. The main problem with the traditional music recommendation system is lack of personalized emotion context. A person will be expecting to suggest better songs according to their mood. But when an app plays a song which is not suitable to his emotion, then this will completely remove the emotional touch. So, we are going to introduce an system which recommends songs based on our emotions and improves the user experience. Introduction to our project. In this, we are proposing an emotion based music recommendation system which is implemented on Spark. Basically, our idea is to improve the music listening experience because music has the ability to evoke strong emotions and can bring people together. Many people find great joy and fulfillment in creating and performing music, and it can be a powerful tool for personal and social transformation. The emergence of digital music platforms and streaming services has opened up new avenues for crafting music recommendations. So, we wanted to integrate AI algorithms in the field of music. Now, let's see the architecture of our project. Data flow. The steps followed in the data flow are data pre-processing, feature extraction, clustering, and model used is random forest. These are the steps we follow to train the data and build the model. Song recommendation. Our system operates by suggesting songs that belong to specific clusters such as happy, sad, neutral. This recommendation is to provide an enjoyable listening experience. We have implemented our project on Spark due to its capability to handle large datasets. In Spark, we have used Databricks as the runtime environment and we have used Spark ML library, vector assembler, and min-max scalar. Finally, we will conclude with our results of our project. This is the basic overview of our project and every step will be detailedly explained by our teammate.
So here we discuss about the data flow, recommendation system, Spark, and results and conclusion. So let us see these in detail. So coming to the data flow, so we have a data of 36,000 songs from Spotify, so which are basically released in the duration of 2002 to 2020. And all these songs which we have selected here, they have 9 features. So the features like the loudness, violence, energy of the songs, etc. So taking these 36,000 songs, we used k-means clustering and we made the 4 clusters which are happy, sad, neutral, and discuss. So after making these clusters, this pre-processed data is trained to a random forest model, and where we have given the labels as happy, neutral, sad, and disgust. So after training this model, so we used it for the recommendation system. So in this process, we have a song selection criteria where the clusters are identified based on the user input. So whatever the songs the user will be given, so the clusters will be identified based on that. And then we have the popularity filter where we select only 85% popular, I mean the songs which are popular above 85%, they are only chosen. And we have the data completeness, so where we ensure a complete list by avoiding any incomplete metadata if it is there. Coming to the data features, as we discussed, we have 9 data features here. The features like danceability, duration, energy, and the loudness, etc. So all these features are shown here graphically also. So this is how we have done with the data flow, starting from the 36,000 songs and building a recommendation system. And now let us go into the further details.
In our project, we have harnessed the power of Apache Spark to revolutionize music recommendations. Let's delve into how Spark made it all possible. We have begun by storing our extensive dataset, comprising 36,000 Spotify songs in our Amazon S3 bucket. This choice ensured not only reliable data storage but also scalability, allowing us to efficiently access and process music data as needed. To ensure a seamless and smooth Spark application execution, we've utilized the Databricks runtime version. It's a key factor in our ability to process vast datasets without a hitch. And lastly, our Spark cluster was configured with 2 to 8 worker nodes. And here's the magic, it's adaptive. Dynamic scaling means the cluster adjusts to varying workloads, guaranteeing efficiency at all times. Now let's talk about the Spark's core strength, distributed processing efficiency. We have a monumental task at hand, managing a dataset of 36,000 songs, spanning nearly 2 decades. It's a lot, but Spark's distributed processing capabilities allowed us to handle it seamlessly. We've configured our Spark cluster dynamically. This flexibility ensured that we can adapt to changing workloads with ease. Thanks to Spark's parallel processing, the times for tasks like clustering and model training were significantly reduced. This means the system will get quicker results and it will be more responsive. Spark clusters were optimized for high CPU and memory resources, specifically with the i3.xlarg instances. This configuration was crucial for our data and memory intensive workloads. All this hard work culminated in our emotion-based music recommendation system, has achieved an impressive model accuracy of 91.8% with random forest classifier. This accuracy isn't just a number, it's a testament to the capabilities of the Spark framework by using Scala. Through this, we've shown that technology can provide a more immersive and tailored user experience, enriching how we can connect with music in the digital era. Our project is a glimpse into the future, where technology understands and caters to your emotional needs. Now Gagan will take you through the code.
Okay, now let's go through the code and implementation of Spotify song recommendation using Apache Spark and Scala programming language. Before execution of Apache Spark code, we have to create a cluster. So I have created this cluster, and if we look at the summary of this cluster, we have been allocated 2 to 8 workers as it is a free tier account, and each worker has 30.5 GB memory along with 4 cores. And we have been allocated one driver program or driver node which aggregates all the information which it receives from each worker node, and this driver node also has 30.5 GB memory along with 4 cores. So if you look at the performance part of it, the Apache Spark version we have used is 3.4.1 and the Scala programming language is 2.12. Initially, we have linked the Databricks account with my Amazon AWS account. So this Amazon AWS account, it allocates the worker types and driver types. So the allocated version of worker and driver types are i3.xlarg, which is provided by Amazon EC2 with 30.5 GB memory and 4 cores. So this is the overall insight about cluster. So if we go to the S3 management console in Amazon AWS, actually we have uploaded our dataset into Amazon S3 for the retrieval into Databricks account. So Spotify songs CSV is the bucket that we have created, and if we go into it, songs.csv is the dataset that we are working on. So these other 3 buckets called workspace Spark bucket, these are automatically created by Databricks for the execution of Apache Spark programs. And this is the AWS part of our project. Coming to the code and execution of Spotify song recommendation, we have imported the sql.spark session. So here we have created a Spark session with a name Spotify song recommendation. What it does is, if this session is already created, it retrieves it. Otherwise, it creates a new Spark session. So into the S3 URL variable, we have taken the dataset path of the S3 object. So we are reading the dataset here from the S3 bucket. So if we print the schema of this data frame df, we have got the following columns: acousticness, artists, danceability, energy, explicit, popularity, year, and all. So what we have done here is we have filtered the songs that came after 2002, because the songs which have come before 2002 or older songs, users doesn't tend to show much interest on them. So we have filtered the songs into after 2002. So what we have done here is we have checked if the dataset contains any duplicates, and we have got that home appeared 24 times in the dataset, you appeared 17 times in the dataset, and so on. So the next part of pre-processing is dropping the duplicates. We have dropped the duplicates which appeared more than once. So we have taken 4 columns: danceability, energy, valence, and loudness as our feature columns, and in these columns we have converted the numerical values into double data type for the execution of model. Also we have taken 2 pre-processing steps, and these are spark.ml.vector assembler and minmax scaler. What this vector assembler does is it takes a set of feature columns and it converts these set of feature columns into a single feature column. And the second pre-processing step is minmax scaler. It takes the features that we have created from vector assembler and it creates a new output column, scaled features, after normalizing the features. Next, we have used k-means clustering method. We have defined the k-means clustering method here. We have taken 4 clusters for happy emotion, sad emotion, neutral emotion, and disgust emotion. This k-means model, what it does is it takes the features column, scaled features, and it clusters them into a cluster column. Then we have fitted the k-means model by giving it the scaled data frame data. So in the cluster column we have got these cluster IDs from 0 to 3. Next we have grouped the clusters and counted the number of songs in each cluster. So for cluster 1 there are about 3600 songs. For cluster 3 we have 10,500 songs. So what we have done till now is we have been given an unsupervised data with only the feature columns and no label. So after using k-means clustering method, we have got the labels for each songs. Like for each song we have got the cluster to which it belongs to. So we have converted the unsupervised data into supervised data. Now we can train a random forest classifier by feeding all this data to it, and in future we can easily predict new songs using this random forest classifier. Also we can check the accuracy of our k-means clustering method. So into the y column we have taken the cluster column, and into the x column we have removed all these name, artists, ID and all, and we have kept all the numerical features into it. Then we have divided the dataset into test dataset and train dataset. We have taken feature columns, acousticness, danceability, and all into the X variable. We have applied all the data pre-processing steps that we have discussed above on the X-train dataset. Here we have defined the random forest classifier, which takes the cluster as the label column and the features as the features column. We have fitted the random forest classifier by giving it the X-train assembled data. And for the evaluation purpose, we have used the multi-class classification evaluator, which takes the true values as cluster column and the predictions as prediction column. In the same way, we have applied the data pre-processing steps on the test dataset as well. Here we have got the predictions on the test dataset. So we have applied evaluate function on evaluator class by giving it the predictions and the clusters. So we have got about 92% accuracy. So this random forest model has a function called feature importances, which gives us what features are the most important for classifying the song features. So after sorting these features, we have got valence, energy, danceability, and loudness are the 4 most important features for the classification purpose. Then we have sorted the data frame based on the popularity. So this function takes care of the recommendation part of our project. What it does is it recommends 10 songs based on the sample dataset it takes, and if we give it a happy emotion, what it does is it filters out the songs which are in cluster 2 and with popularity greater than 75 with the name not as null. For each song it does the same, and if we look at the recommendations, if we give it the emotion as happy, it has recommended the following songs. For emotion sad, it has recommended these songs. For disgust, it has recommended these songs, and for neutral as well. So this is the code and implementation part of our project.
So this is all about our project, and here are the team members. Thank you.